everyone, we're going to write a trig expression as an algebraic expression containing u and v for this expression. So basically we have secant of alpha plus beta. For secant we're going to use the cosine. So we're going to be using this formula here. Before we get started, let's let alpha equal tan, inverse tan of u. Therefore, tan of alpha equals u. And for our beta, we're going to let that equal inverse cosine of v. So tan or cosine of beta equals v. Now notice in our formula we need sine and cosine. So let's get sine of beta. If we do sine of beta, that equals square root of 1 minus cosine squared of beta. I'm using my Pythagorean identity and just square rooting both sides. So that's going to equal square root of 1 minus v squared. So this is square root of 1 minus v squared. Now for this one, we're going to use this identity, and I'm going to use secant squared of alpha equals tan squared of alpha plus 1. Again, if you take the square root of both sides, I get rid of that. I have square root of that. So that's going to equal square root of u squared plus 1. We actually need cosine of alpha. So cosine of alpha equals 1 divided by square root of u squared plus 1. So we have almost everything. We have our cosine of beta, we have our sine of beta, cosine of alpha, and now we need our cosine of beta. So for, not cosine of beta, but sine of alpha. So sine of alpha equals square root of 1 minus cosine squared of alpha. So this is going to end up being equals square root of 1 minus 1 divided by square root of u squared plus 1. Now to put under these, both under the radical, we can write this as this equals square root of 1 minus 1, and this is I'm going to put this under the radical, so that's just going to be u squared plus 1, and that simplifies to square root, if you have the common denominator, u squared plus 1 minus 1 divided by u squared plus 1. So that cancels. The square root of u squared is just u, and then we still have square root of u squared plus 1. So keep these in mind while we use our sum and difference formulas. We have sine of alpha equals this, cosine of alpha equals this, and then we have our cosine of beta and our sine of beta. And we're going to use our formula now. So we have a secant of alpha plus beta. That's just going to equal 1 divided by cosine of alpha plus beta, which is 1 divided by, and we're going to use this formula here, which is cosine of alpha times cosine of beta minus sine of alpha times sine of beta. And then once we're going to just use substitution. So this equals 1 divided by cosine of alpha was 1 divided by square root of u squared plus 1. Cosine of beta was v. So I'm just going to multiply this by v, this 1. Minus, and then we have u, for sine of alpha is u divided by square root of u squared plus 1 times sine of beta was square root of 1 minus v squared. Now I'm just going to add that to the numerator here. So I'm just going to multiply this by that. So it's going to be 1 minus v, square root of 1 minus v squared. All right. Now, our common denominator is u squared plus 1. So I can rewrite this as 1 divided by u squared. Well, that's what we have. So 1 divided by v, let's write this out, v minus u times square root of 1 minus u squared divided by square root of u squared plus 1. All right, now with the division properties, I can just move that up there. So our final answer is square root of u squared plus 1 divided by v minus u times square root of 1 minus v squared. And that's it. Thank you. Have a nice day. Bye-bye.